And we're back. Hello, everybody. Good afternoon. Um, I hope you can hear us. We apologize for the delay. We were having some technical issues. Apparently, some people from the office went to Gamescom in Cologne and took all our microphones. So we are very in a very improvised setup today. So I apologize for the sound quality in advance. And today I have with me Julie. Hello, Julie. How are you?
Hi, I'm good.
Great.
Hi, everyone. Yeah, do let us know if there are any problems with the sound. If someone could let us know if you could hear us all right. Like Jay said, we've improvised a bit today with the sound and the microphone. So yeah.
I tell you, the nerve of some people taking the microphones without letting us know. That's. I'm gonna do something about it.
Yeah.
Okay, so let's switch to. How about you should be able to hear us now. Can anybody confirm if you can hear us? Yes. Okay, brilliant. Cool. Yeah. I want my microphone back. Damn it. Anyway, so as we were saying, so when the game begins, you can see that the camera position is okay, right? Uh, you can see a whole lot of the world. The seagull is far away, but as the seagull grows bigger, it can become a problem because then you can no longer see the
The
tail.
chips he's eating.
Yeah, that's
Nice.
chips, and then a shark. And then it becomes way too big, occupying too much of our space. So ideally, so let's say that my fist is a seagull, and the camera starts here. As the seagull grows bigger, we should have the camera going farther away and up, like in a diagonal, right? So this is what we'll be doing today. We'll be moving the camera farther away from the seagull. One thing I'm going to do before we begin is I've been tinkering around with the project, and I feel like uh, the camera is too far away uh, from the seagull at the beginning. I don't know. I feel like it makes it harder to aim and to actually be able to eat uh, the the food. So what I'm going to do is I'm going to bring the camera a little bit lower and a little bit closer to the seagull, like this.
So that you're just dragging something, or
Yeah, I'm just adjusting the position of the camera. So our camera is using a Unity component called Cinemachine,
Mhm.
which is like this amazing component that just helps you set up cameras. It's pretty cool. It was hell to create cameras before Cinemachine, but now it's much better. And I'm just adjusting this parameter here. It says follow offset. So I'm telling the camera to follow my seagull and to look at my seagull, and I'm just saying that your offset should be here's a seagull. You should be slightly up and slightly back of the seagull, but looking at it. So the camera is like this, right? So that done, what I'm going to do now is we're going to require a little bit of manual labor before we actually get into the nitty-gritty of it. Because what happens is we've been using Unity's visual scripting and Cinemachine. And Cinemachine is a package that you add to the project. It doesn't start installed by default in your project, so you have to put the package in the project. Because of that, by default, Visual Scripting cannot see Cinemachine and its components, so I have to go to my project settings, visual programming, there you go, Visual Scripting, and over here if I expand these type options, I can see all the types that are available within Visual Scripting, and I'm gonna add three new types here. I'm gonna add Cinemachine virtual camera.
So do these come part of the package?
Yes, these are all part of the Cinemachine package.
Yeah.
Cinemachine virtual camera, Cinemachine component base.
Can you get Cinemachine on the Unity Asset Store?
No, you get it on the package manager. So
Okay.
Window, package manager, and over here, here's Cinemachine.
Nice.
Yeah. And finally, we're gonna add the Cinemachine transposer. After I do that, I'm gonna click regenerate nodes, and once that's done, these packages are gonna be available on Visual Scripting. As we import, I'm gonna say hi to Natalie and Master Proctor. Hello.
Hi,
Anybody
guys.
else? Send a hi in the chat. Let us know that you're here. And as usual, if you have any ideas for the game, we're still having problems figuring out what should happen when our seagull poops. It is given that it's going to poop at some point. We need to figure out what it should do. Julie, do you have any ideas?
Are we gonna add any humans or anything?
Oh yeah, there will be humans.
Could it be like a second game that it has to poop on the people?
You want to hit people with the seagull poop?
It's meant to be good luck, isn't it?
Okay, yeah, fair enough. That's an idea. I think that's the front runner, to be honest, so far.
Any other ideas out there in the chat?
Let us know. Great. So now that Visual Scripting can see Cinemachine, we can start actually adjusting the position of the camera as the seagull grows bigger. The first thing I'm going to do is, on my seagull game object, I have here the variables, and so far we have the size variable, which is the one that we're using to control, as the name says, the size of the seagull, and to validate if the seagull can actually eat the object. So if the object is smaller than the seagull can eat that object. Otherwise, something's going to happen. We still need to figure out what. I believe I'm thinking about doing something similar to Katamari, which is again the game that is the inspiration for this project. And on Katamari, if you come and try to roll over an object, sorry, Julian, hiding you.
Oh, don't worry.
Roll over an object that is bigger than you. You just bump into the object just bump into it, go a little bit back, and then lose a little bit of size. So maybe that. I don't know. We'll
So
figure
how
it out.
do you like end up lose? How could you lose at this game?
So right now what I'm envisioning is there's no losing. Like in Katamari, there's no losing.
Okay.
Like you have a set period of time where you have to get as big as possible.
Okay.
Right. So of course our level is going to get more detail with more stuff. But the idea is that, when the seagull is big enough, it should be able to eat the trees and the buildings and
Right.
the people and the cars.
So eventually it should eat everything and there's nothing left.
Possibly, yeah. The clouds, including the
Yeah.
clouds.
Okay.
So right now it's just for just for visual effect. The seagull is getting super big when it eats the chips, right?
Yeah.
It should be just slightly bigger, you know. But yeah, this is just to visually show that yes, it is eating, yes, it's becoming bigger. But in the end, it's just going to grow slightly bigger, right? In the end, so if it's the whole row of chips, it wouldn't still be able to eat the shark. It should be
Yeah,
able
yeah.
to it would be able to eat, I don't know, a chair or stool, and then a flower pot or a garbage bin, you know, getting bigger and bigger. So let's start by adding a couple of variables to our seagull. So our seagull, we will need to know who our camera is. So I'm going to create a new variable called camera. And the type of this variable is going to be game object. And the value is going to be our camera. So one thing I was going to do today, but because of our technical issues I couldn't, was just do a little bit of housekeeping on our scene. It's a little bit messy, you know, it's hard to find stuff, but I'm going to have to do that on the next stream. Again, apologies. But anyway, camera game object, I just put my Cinemachine camera here. And the next one, I'm going to create already a variable called objects eaten. And here I'm going to save the number of objects that the seagull have eaten. So besides its size, we're going to have the number of game objects because they're separate, right? Some game objects may make the seagull grow bigger. Some grow a whole lot bigger, some a little bit. I want to keep an actual number of objects that the seagull has eaten. So that's why I created this variable, and then I can use that for our game UI, showing the seagull size and the number of objects. Great. So now I'm going to open. Is it open already? I'm going to open my.
What are we opening?
We are opening now part of the logic of our game. This is called food collision. So this is the code, quote unquote, that controls what happens when the seagull collides with an object.
Okay.
It checks, is this object edible? If it is it big? Is it small enough for a seagull to eat? If it is small enough, seagull's gonna eat it, get a little bigger, make the object disappear, right? So here, what I'm gonna do is I am going to first of all I'm going to add a node called trigger event trigger. Oops, no, not that one. There you go. Trigger custom event. And why I'm creating this? When I eat an object, I want to tell the camera, say, hey camera, the seagull have eaten an object. Now you need to adjust your position. Right? So I'm already preparing the ground here for when the seagull is the camera. It needs to tell when the seagull eats an object, it needs to tell the camera that the camera should move. So, and this event is going to be called update camera position, and this will be sent to the camera game object, which we had just created here on the variables. So I'm going to call here get object variable, object camera, and I'm going to send it here. So right now what's happening here is when the seagull eats an object, I'm going to send the event update camera position to the camera game object. And then the camera is going to do something, which is set its own position. So for now, we're going to leave the seagull. We did everything we need to do. We're going to come back to it in a while. Now, we are going to go to our camera and, hey Dennis, how are you? And we are going to create a new what's the name? I always forget the name. It's not a machine. Is it a graph? A graph. What's the name? Visual scripting. A script machine. We're going to create a new script machine here on the camera, and this script machine is the one that will actually change the position of the camera. So I'm going to create a new script machine, and I'm going to call it camera position controller. Great. I'm going to open. Oh, it's open already. Brilliant. And this machine is going to need some variables. So what I want to do is, when the seagull is an object and the camera is here, it needs to go to a new position. But I don't want the camera to simply jump to a new position immediately. I want it to smoothly go from its current position to its new position. Otherwise, it's going to be weird for the player, right? The sudden change of camera, it just looks weird. So, first thing I'm going to have here is a variable called follow camera target, which is the final position of the camera once the seagull eats an object, and that's a vector 3. So vector 3 is a position in the world, x, y, z, 3D. Next, if I go to my virtual camera here, and I see that I have this part of it called body, and this is where we have the follow offset, which is the variable that will be changing. So I want to keep a reference to my virtual camera body, and the virtual camera body is a CineMachine transposer. So that's why we've added CineMachine and CineMachine transposer to visual scripting, so I'll be able to create this variable here. Next, I'm going to create a variable called lerp factor.
So is there somewhere that people can find this? Are we going to document this somewhere? Or?
Absolutely. So besides the streaming, which is going to be recorded and available, I always forget to mention that. We are sharing this project on Bitbucket. So you can download the project from our repository and you can follow along. We have different branches, each one at the end of one of the streams. So you have stream 1, stream 2. This is going to be branch stream 3. It's going to be available there, so you can download, play around. If you do something with it, show it to us, share it, so we can know about it.
We're always for any of you that are creating anything using Anything World, do share on Twitter with the hashtag Anything World. We love to promote what our users get up to and support the community. So anything you create, do please share. We love to see it.
So I had accidentally deleted the variables I'm creating again. So now I created a variable called lerp factor and one variable called current frame. I'm just not consistent with my variable names. I'm using uppercase, lowercase, all over the place. I'm just going to use uppercase just to follow the standard, but that's horrible. I'm ashamed of myself, but that's okay. So these two integer variables, actually they should be integers, so they floats. These two float variables I'm going to use on a Unity function called lerp. So what lerp does is, that's way too big. There you go. So what lerp does is it interpolates the position of two vector trees. So I'm going to provide the original position of the camera, the final position of the camera, and what lerp is going to do is just going to smoothly move it from the origin to the destination based on a percentage of the number of frames that have elapsed. I go back to documentation here. So, there you go. So lerp happens between values of 0 and 1. On value 0, it's on the origin. On value 1 is in the destination. So that's why I have these two variables, lerp factor and elapsed frames. I'm going to divide the elapsed frames by the lerp factor, get a number smaller than 1, and that's the value that lerp is going to use to smoothly move the position. I've been playing around with it, and I'm using a lerp factor of 1,000, just because the movements are going to be very small. The camera is going to move very little space each time. So if the lerp factor is too small, it's like 10 frames, it's going to seem immediate. So I don't want that. I want it to be a little bit smoother. So that's why I'm using 1,000. But again, you play around with it. You see what feels better for you in your version of the game.
So it's just like a testing and learning.
Absolutely, yeah.
What
It's
what
just
you prefer.
do what you feel it's best.
Yeah.
Right. Cool. So now on my camera control, what's the name I gave to this guy again?
For which one?
For the camera controller graph was camera position controller. I forgot to give it to the title. Camera position. There you go. Now it shows up here, and now I know what this is. You remember when we were setting up our Seagull? Just jump back to Seagull real quick. We have added this custom event called update camera position, right? Which was the event that's going to be triggered, so the camera knows that it needs to move position. So now I'm going to actually create this event on my there you go, on my camera controller. So I create a custom event. Over here I'm going to give it a name. I'm going to call it update camera position. And this will actually receive one argument. So over here, argument 0. So this event is going to receive the size, the size increment of the Seagull, right? So then it knows how much you should move. Because the Seagull, it's something that makes it a little bit bigger, the camera should move a little bit. If you eat something that makes it a whole lot bigger, the camera should move more. So now that I defined that I need this argument, I'm going to go back to my Seagull. Yeah. And I'm going to set arguments to 1 here as well. And I have here the variable size, which is the size of the object that the Seagull has eaten. And I'm going to pass this as a parameter to my custom event. Going back to the camera. Now let's start to create this event. And the first thing I need to do is, there goes our microphone.
Yeah.
Finally moved. I just hope that the audio,
Is it still working?
it's still there, yeah. I'm gonna get here an integer -1. And what I'm going to do, the first thing is I'm going to get this argument, which remember is the size, and I'm going to multiply it by -1. And why I'm doing that? Because here's a Seagull, right? And here's the camera. So if the Seagull is moving this way, so this is the z-axis, this is the y-axis, and if my camera is going to move like this, so it's going to move up on the y-axis, so that's positive. But it's moving backwards on the z-axis, so that's negative. So this value should be negative, and that's why I'm multiplying by -1. And now that I have this value, I'm going to create a new vector 3. And over here, on x, I'm going to keep it 0 because I'm not moving it in the x-axis, which is the x-axis. Actually, it's shown here. I'm doing it with my hands.
Well, you can see it on the Seagull.
Yeah, of course. Why am I doing this with my hands?
The green, red, and blue.
Yeah,
arrows?
exactly. So, there you go. So the blue axis is the z-axis. So it's the axis of the Seagull moving forward. The green one is y, and the red one is x. X is the sideways axis of the Seagull. So in the z, I'm going backwards. So I should be negative. Gordon.
Go ahead and say.
Yeah, it's
We'll blame Gordon for stealing the microphone.
We'll talk about this later when you're back. So, sorry, I'm gonna take the original value, put it on the y-axis, and the negative value, the value multiplied by -1, and put it on the z-axis. And I'm not gonna change the x-axis, so that's why x is still 0. Now, I am going to get my virtual camera body variable, which is my Cinemachine component, and from here I'm going to get the there you go. I'm going to get the mfollow. No, that's not this one. Okay, let's follow. Oh, there it is. Okay, not set.
So a lot of them that are very similar.
Yeah, exactly. And I am. There you go. Get and follow offset. So follow offset is this variable here. Is this vector 3 that is saying that right now is at 0.39 and 1.85 on the z. So I'm going to get this variable here from my Cinemachine component. And what I'm going to do now is I'm going to add these two vector 3s. So I'm going to get the position of the camera, and I'm going to add the change that I defined. So if our camera is here, it's going to go a little bit up on the y-axis and a little bit back on the z-axis. And then I am going to set my follow camera target to this value. There you go. So, in a nutshell, what I'm doing here is Seagull is an object. And Seagull tells the camera, hey camera, you need to adjust your position. Here's how much you need to adjust it. The camera receives this information, and what you do is it gets its current position, adds the new position, and instead of immediately changing the position of the camera, I'm just adjusting this follow camera target variable. And it's going to become clear what we're going to do with that in a second. Great. Now, just going to move this a little bit down so we can have space to play around with, because this one's going to be a big one. Now, I'm going to go to my onStart event, which happens when the game object either is activated in the scene or when it shows up in the scene for the first time. In a nutshell, that's it. So, what I need to do is I need to set some variables here. And what I'm going to do is, first of all, get my component of the type Cinemachine virtual camera. So I'm essentially getting this guy here. And then, from this one, I'm going to
So is this how you start the game you're setting up, or?
Yes.
Yeah.
So this is going to happen when the game starts.
Yeah.
And what I'm doing is just setting the virtual camera body variable. So on the update, I have a reference to my camera. So I'm going to get the component, the component body of my Cinemachine, which is the one that contains the follow offset variable. And then I'm going to call set graph variable. I'm going to set the variable virtual camera body and just apply this component that I got here. Oh, it's missing this. There you go. And finally, I want to set my, what's the name again? My follow camera target to the current value of the camera. So my follow camera target starts at the same position as the camera, and that's going to become clear why we're doing that in a moment. So I'm going to copy and paste this set variable node. I'm going to call follow camera target, and that's going to receive the follow offset, the current follow offset. So when the game begins, the follow offset is 0, 0.39 minus 1.85. Our follow camera target is going to have the exact same value. Great. So now we're going to the meaty part of the camera movement, and that happens on the onUpdate event. Now, the onUpdate event, it happens whenever the game redraws the screen. So if your game is running at 60 frames per second, onUpdate is called 60 times per second. So because I want to move my camera smoothly, I need to do that on my onUpdate function and using the lerp function. Lerp stands for linear interpolation. And it's just a fancy way of saying
good memory.
Move this thing smoothly. Great. So what I'm going to do on my updates, first of all, I need to check if I actually need to move my camera. And how do I do that? I'm going to get the current position of my camera and compare it with the follow camera target, which will be the final destination of my camera. If they're the same, then I don't need to move the camera. If they're different, then I need to move my camera. So that's the first thing I'm going to do. So Proctor is asking, what are your thoughts on update versus fixed update? That's a good question. So the difference between update and fixed updates that, as I said, if your game is running at 60 frames per second, you're going to have update running 60 times. If your game is running at 120 frames per second, update is going to run 120 times. If your game is running at 10 frames per second, update is going to run 10 times per second. Whereas fixed update, as the name says, it runs a fixed number of times. I believe you define the number of times fixed update runs per second. So the advantage of fixed update is that it's going to run the exact same number of times independent of the performance of your game. And that's ideal, especially for physics-based operations. So if you're using a rigid body and you're moving the rigid body, you should always move it on a fixed update, not on the update. Otherwise, you may have issues. Fixed update also ensures that whatever operation you're doing is going to be done the same number of times, again, regardless of the number of frames per second that your game is running on. So what we're going to do here for the moving of the camera, it's fine to do on fixed update. It's okay because it's not physics related and it's not, you could say it's not critical to the game, but if you're doing movement, especially if it involves physics, it should definitely be done with fixed update. We're preparing some very cool material that we're going to announce soon, so stay tuned, where we cover fixed update and update on a more clear manner. But over here, moving the camera and update is fine. I hope I made that clear, Proctor. So, as I said, I want to compare the position of the position of the camera and the position where the camera should be going. So I'm going to get these two variables. So I'm going to get, first of all, I think I have a get variable, right? I don't. But get graph variable, and I'm going to get the virtual camera body. I'm going to get the oops. I'm going to get the follow offset, and I am also going to get my follow camera target here. And now I'm going to compare them both. So I'm going to add a node called equal. And this node receives the two variables, and it has an output, and this output is going to go to an if node. So I'm comparing both variables over here. If they're the same, then that means that this if is going to go to the true path, and over here I'm going to do something that I'm going to do right now. But if they're different, that means that I need to move my camera. And if I need to move my camera, I'm going to have to do the lerp.
Parker says thanks for the explanation.
Oh, my pleasure.
Yeah.
If you have any questions, just drop them on the chat.
Yeah, any questions, drop them in the chat, or comment on social media, and we can do more explanatory social posts. We're always looking for new content, and education is really important to us. So any way we can help, we'd be more than happy to.
Absolutely. That's 100% true. And okay, so if it is false, I'm going to do the lerp. And this is where things are going to be a little bit tricky. If you have any questions, if it seems a little bit odd, let me know. But, so what I'm going to do on my lerp, first of all, I'm going to set my origin, which is this top vector tree, and my origin is my current follow offset. My destination is going to be my follow camera target. And finally, I need to define here the third value, which is the interpolation index that goes between 0 and 1. And this is going to be based in the number of frames that have passed divided by the lerp factor, which I've set for 1,000. So first thing I'm going to do, I'm going to get the variable current frame. I'm also going to get the variable, let's just put it up, the variable lerp factor, and I'm going to divide my current frame by my lerp factor, which should be a number between 0 and 1. Then I'm going to get this, I'm going to apply it as a interpolation factor. Once I've done it, I can now first of all set my current frame variable to literal, and I'm going to do an add in addition. So now what I'm going to do is I'm going to get my current frame and I'm going to add 1 to it because a frame has passed. I'm going to set this variable. So every update I am increasing the value of current frame. So in the current frame is 0, then next is going to be 1 and 2 and 3 and 4 and 5, and I'm always be dividing by 1,000. And finally, I can now set the follow offset variable. So I'm finally actually changing the position of my camera. And the new position of the camera is going to be the result of my linear interpolation. Right? A little bit complicated. This is where visual scripting is a little bit worse than actually coding a program, because you have like operations like this, a division or an addition, and it's a whole bunch of nodes, and it's really weird, whereas in coding is going to be one line. For these cases, it's a bit odd, but overall it is pretty good.
So could you use this for any object? Not just like the flying seagull, if you had like a running elephant and you needed to move the camera.
Oh, absolutely,
just
yes.
Follow this process.
If you want to move the camera smoothly, right?
Yeah.
If you want to move it immediately, it's simpler, but especially on a live stream, why make it simple, right? More moving parts, bigger chance to break. and that's why
Mm.
we that's why we're here.
They're asking if we can zoom in a
Zoom
little
in.
bit.
Absolutely.
Probably
yes.
quite small.
Unfortunately, this is as big as it goes. Another another aspect of visual programming is that it's very new to Unity, so there's a little bit of some limitations to it yet. You know,
Yeah.
don't want to badmouth Unity, but Blueprint in Unreal work much better. For now, you know, it's gonna get better. But anyway, we still need to figure out what to do when the camera is in the position that it's supposed to be, which is basically in the beginning of the game, and when the camera is moving, and finally gets to the actual position. And when that happens, I simply want to reset the value of current frame, because I've been increasing it here. So let's say current frame ends on frame number 857. But when the camera moves again, I want it to start from 0, not from 850. So over here, I'm going to get this. Ooh. Oh, God. I am all fingers today. I'm going to set the current frame variable to 0. So this way I reset the current frame, and when my seagull eats something new, I'm just going to reset the alert process. And the cool thing is that my seagull eats an object, and my camera may be in the process of moving to a position, and before my camera arrives to the position, my seagull can eat another thing. And that's okay, because I simply update the follow camera target variable, and the alert process just continues smoothly by itself. So I don't have to worry about it. So that's, you know, it's nice. Cool. Are we ready to do our thing? I think we are.
And what is that?
Our thing is we're going to run the game, the seagull is going to reach an object, and the camera, fingers crossed, should smoothly move.
Right, let's have a look.
Okay. Hope it works. I'm always nervous when I do these things, especially live, because I always forget something, or knock on the wood, Unity crashes. It happens. See how long it's taking for Unity to run?
Oh, here we go.
I'm nervous already. Ah, there you go. Cool. So, there goes our seagull. And I am going to eat a chips. Let's see if our camera moves. Hey, look at that. The camera moves, and it moves smoothly.
Nice.
And as you can see, now I can see the whole seagull.
What if he eats the shark?
There you go.
Nice.
And the camera moves super smoothly. See? I mean, there are some considerations to make. So first of all, I am still increasing Y. And because the camera is set to always look at the seagull, I'm going up, and at a point, our camera is going to be like way above my seagull, and that's not what I want. So an improvement that can be done, and which I'm gonna do, is just clamp a Y position, limited Y position to, I mean, a reasonable point. And maybe the same is true for the Z, right? Or maybe don't move it that much. I don't know. It's something, again, as I said with the movement. It's something that you need to test by yourself, see what works for your game or what you're doing. It's trial and error. But it's working. That's great. One thing I would like to do, and again, I don't know if I should do this.
What are you gonna do?
I wanted to disable alert, so you can see the difference between the smooth movement of the camera and the immediate movement, and how it would be unpleasant, I believe. Let's see.
Is that easy to do?
It is, but we're live, and that makes me nervous. So, but anyway, I think we can, okay, I think we can do it. first of all, I'm gonna disable this on update. I don't want to do the lerp anymore. I'm gonna get the set follow offset variable, and here, when I set the follow camera target, I'm going to immediately also set the follow offset. I think that's going to work. Let's see. So, just a quick recap of what I'm trying to do here. Custom event, Seagull wake an object. They say, hey camera, I just ate this. Adjust your position. And instead of simply saving the new position of the camera, I'm also immediately setting the follow offset to that position. So fingers crossed. Let's see if that works.
Right.
Okay, we're getting closer to the chips. Let's see. And boom. See how immediately the camera moves, and that's
It's a bit, yeah, jerky.
yeah, it's weird, right? And I think it's unpleasant for the player. So that's, you know, that's not nicer as moving smoothly. So one thing that we can adjust is when the seagull becomes bigger, maybe it should be faster. It feels low now, right?
Yeah.
But you know, again, something that we can explore on other streams. I think to wrap up today, I'm going to just bring back,
Can undo it.
yeah, undo this horrible thing, and maybe just to see the difference. Let's just make sure that we're back to the working
Smooth
camera movement.
yeah.
Yep. Is it smooth? Okay, so yeah, it is.
Yeah.
Oh, you know what is not smooth is the growth of the seagull. Maybe it's something that we could work on. Maybe, I don't know. Yeah, I think that's so. To wrap it up, just so we have an idea of the difference, I'm going to. So right now, what happens is each of the edible objects have this variable named size, which is essentially how much bigger the seagull is going to get when it eats this object. Right? Originally, I had envisioned the French fries would have a size of 0. The seagull starts with a size of 1.
Mhm.
So anything smaller than 1, the seagull can eat.
I see.
For the final game, does the collider adjust the size increase of the seagull? Yes, it does, Brock. Good question. The seagull collider gets bigger as the seagull gets bigger as well. Just so you know, so I have a parent game object for the seagull. Where is it? There it is. And that has the box collider. And what I do, I simply adjust the scale of this object. So the object gets bigger, the collider gets bigger. So, you know, so the seagull is going to eat more stuff. So originally, back to the French fries, I had envisioned it to 0.1.
Mhm.
It will be like the first object that seagull will be able to eat, so it gets slightly bigger. But for visual representation, we had switched to 0.9. But let's just switch to 0.1 again, just so you have an idea of how it would look like on the final quote-unquote game. 1. And then one cool thing is that I'm going to eat all these tiny French fries now. The seagull is going to get slightly bigger, and I won't be able to eat the shark because the shark size is 8. So I'm not going to be able to eat the shark. So let's see what happens. I'm going to run game, and go. There's the seagull. And now I'm eating. So you see that the seagull is getting slightly bigger.
Tiny, yeah.
Slightly bigger.
So what are we at now?
The
1.5?
seagull
What
size. The seagull size right now is 2.5.
2.5, okay.
Yeah, and if I try to eat the shark, I won't be able to.
You just
and I'm just flying through the shark. But again, probably. Sorry, go ahead.
That's where you want to add that you just bounce back.
Yeah, exactly. Bounce back, and the seagull maybe loses a little bit of size. Go from 2.5 to 2.4, 2.3. I don't know. We're gonna have to play around it. That's it for this week. Julie, you want to talk about? As I said, we have some of our teams in Cologne.
Yeah.
For Gamescom and DevCon. They've taken our microphones, led us in this horrible situation we're right now. Shame on them. We love them yet, but still, you know. But we're going to be on a whole lot of events, right?
Yeah, so if you can't tell, I'm not Jay's definitely the technical one here.
I'm sorry, have you been on stream before?
Yes, I have been on one before.
Okay. Because I haven't introduced you, and I'm such a weird
I'll introduce myself again. So I'm head of marketing here at Anything World. So one of the big things that I focus on is all the events that we go to. So like Jay mentioned, the team are out at DevCom, which wrapped up yesterday, and they're at Gamescom today. So if anyone's out there, make sure to send us a message on social, and you guys can meet up. We're also at quite a few other events over the next couple of months. So the next one that Seb, one of our co-founders, will be at is AWE in Asia. So he is speaking at the event in Singapore about AI and gaming. So if you're out there, make sure to check it out. We will also be at WASD, which is actually a local event to us. So we're based in the Truman Brewery. And that's also where the event is going to be hosted. So if you're around, definitely give us a shout. That is from the 14th to the 16th of September. Gordon, our other co-founder and CEO, he's going to be speaking there in partnership with Into Games. We're actually also doing Games Jam with them early October, so keep your eyes peeled for that. And Gordon's going to be giving a talk about how to use Anything World in a Games Jam, so that should be really exciting. Definitely recommend for you guys to check it out. A few of the other ones that we'll be going to, actually Jay, you're going to be going to the Unity Developer Day.
I'll be at Unity Developer Day
also
in Brighton.
in September. So if you're there, hit up Jay, and I'm sure he can give you a demo, or you guys can talk about the Seagull game. And then we have a couple of other ones later in the year, the Web Summit in Lisbon, and also Unite in Amsterdam. So lots of upcoming events. If you're at any of them, make sure to hit us up, come check out our booth. We have lots of cool merchandise, t-shirts, stickers, lanyards, pins. We would love to see you guys. So those are all the events. Keep your eyes peeled on social media for a recap, because it's quite a lot of information to take in. Would love to meet all of you guys. So I just wanted to share that with everyone.
Absolutely. And these are the ones that are in the agenda. Maybe new ones that are popping.
Definitely.
But again, look us up on social media. We have our Discord server, and you can find it on our website, anything.world. Join, let us know, give us a shout. We always want to hear from developers.
Any feedback. We're also on the Unity Asset Store. We mentioned that a couple of weeks ago. So if you are using Anything World, we would love for you guys to give us a review on the Unity Asset Store. This helps other people looking for packages to download. And as you can see, it's free.
Yeah, it's free, and it's good feedback. If you have any feedback, just put it on the reviews, and we'll be more than glad to help. There's people already put some feedback. We replied. Always glad to reply. And that's it.
That is it.
Thanks,
what about
everybody.
next week? What's the plan for next week?
Next week we will do the UI of the game. So show the seagull size and how many objects it has eaten. Maybe we can do the LERP for the seagull size increase as well, so you can log a boop, 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 boop. And maybe if I'm able to put it together, we'll have the bump on big objects logic.
Perfect.
Yeah.
Very exciting. Okay.
Brilliant. Thanks a lot, everybody, and see you next week.
Bye.